Alright guys, so this video is going to be on polynomials again, alright? So yesterday, or I should say the last video that I recorded, because I don't know how many days we're going to spend on it, but the last video I recorded was on polynomials, just adding and subtracting them, okay? So this video is going to be on multiplying polynomials. So real quick, this should be a semi-short video, or I don't know, maybe I'll touch on more than just multiplying. Maybe I'll do a little bit of multiplying and adding together. Maybe an application problem or something like that, but it's a pretty simple video. So real quick, let me talk about what a polynomial is. And a polynomial is pretty much just an expression, right? So I'll just write out an example so I can talk through what I mean by an expression. Okay, an expression is just when you have some amount of terms together, right, but it doesn't really equal anything. If it equals something, then you call that an equation, but here's an expression, okay? So what a polynomial is an expression, right, where you have multiple terms, right, so multiple terms. So you've probably heard of things like a binomial. A binomial is an expression where you have like bicycle, right, two terms. Okay, or maybe I can put a plus 2. Here's another example of a binomial. Okay, and then there's such a thing as a monomial. That's one term. Okay. And then this nomial part. So you're looking at the prefix to determine how many, right? Monomial 1, binomial 2, many. Nomial is just another word for number. So when you see something like what I just had, 5x squared plus, let's just make something else up, 8x minus 16, these are just numbers. Even though they have variables in them, realize that that variable is just it's a variable number. So if x equaled 3, then this number would be 8 times 3, which would be 24, which is just a number, okay? So polynomial, many numbers, binomial, 2 numbers, monomial, 1 number. Okay, and the terms were each of those numbers, right, that are separated by the plus or minus signs. All right, so we're multiplying polynomials. And I'm working out of this book, and I don't know if I'm going to be able to put this book. I might be able to make some copies, photocopies, and put them up next to this link. But regardless, if I don't have it there, then what I would do is just pull out a separate sheet of paper and take some notes. It's straightforward enough. But let me just start by working through a few examples here. Let's see. Let's do this one. So we have 4x plus 3 multiplied by x minus 2. Okay? Now notice the difference in the other video, the last one, where you're adding and subtracting, there's an addition or subtraction sign in there. Now there's nothing there. It's multiplied. Okay? So when you multiply two polynomials together, in this case two binomials together, you want to multiply each term, right, in this first parentheses by each term in the second parentheses. So what I typically do, and they'll teach you things like FOIL, multiply the first things, the outer things, the inner things, the last things. I don't like to do that because when you get out of binomials, things stop being foiled. I don't know if you guys are familiar with that, but a lot of people are. So I just multiply everything in here, every term in here with every term in here one time. So I start off with 4x multiplied by x. 4x times x is 4x squared. Then I take 4x and multiply it by negative 2. 4x times negative 2 is negative 8x. And now I'm done using the 4x. 4x has been multiplied by everything in here one time. So I'm done with that term. Now 3. 3 times x is plus 3x. And then 3 times negative 2 is negative 6. So now I've taken 3 and I've multiplied it with each one of the terms in here. So I'm done using that, and I've officially multiplied every single term in here by every term in here once. Okay, so This is my expression now, my polynomial. I'm going to combine like terms. So this has no like term, so I'm just going to leave it. Minus 8x plus 3x. So when these get added together, I end up with a negative 5x. Okay, that's combining these like terms. We've written that one here. Minus 6. Okay, and that's my new polynomial. And it's as simple as that. Let's go ahead and do a few more so you guys get the idea down. I want to find a tougher one. That's a good one. We can do another one of those or one like that. Here's a great example. Okay, so, and the reason this one's going to be a great example, this is 5x plus 3. I realize I kind of messed that up when I wrote it. X squared minus x minus 4. The reason this is a great example is because I wanted to prove why, and this is only a great example if you use FOIL. I don't like teaching people to use FOIL just because now we have a binomial multiplied by a trinomial, okay? So FOIL is not going to work. So you can't do a first, so this is why I keep saying first, outer, inner, last. You can't do this with these because there's no definite, let's say like, if you do the first terms, the outer terms, the inner terms, and then the last terms, you skip this middle term. All right, and that's why I don't usually like to teach FOIL. So again, easiest thing to remember it by, take every term in this first parentheses or this binomial, multiply it with every term in this trinomial. So I'm going to start with 5x times x squared. So I'm going to have 5x cubed. So 5x times x squared is x cubed. All right, 5x times negative x. That's negative 5. X times negative x was going to be that x squared. 5x times negative 4 is negative 20x. And if you want, if you need some tutoring on like how to multiply variables and how to multiply numbers or numbers and variables together, you can come ask me that sometime separate. But it is straightforward. So notice I'm just multiplying any number with any number. If I'm multiplying 5x and x squared, I'm multiplying any number, so 5, with whatever number's in front here. So in this case, it's just a 1. So 5 times 1 is 5. And then any variables together. X times x squared is x cubed. All right. So I've multiplied 5x with every term in this trinomial. So I'm done using that. Now 3 with every term in this trinomial. So 3x squared. 3 times negative x is negative 3x. So remember that's a negative 1. So 3 times negative 1 is negative 3. And then x times, there's nothing there. So negative 3x. And then 3 times negative 4, negative 12. Now I've officially multiplied 3 with everything in here. So I'm done multiplying. Here's my polynomial. I need to combine some like terms because there's a lot of stuff here. So 5x cubed has no terms to be combined with. Negative 5x squared and a 3x squared is going to be a negative 2x squared. Negative 20x and negative 3x is negative 23x minus 12 by itself. Okay, so there's another example. Let me make up one more example. I'm just going to make this one up instead of going out of the book. Let's say we have 2x squared plus 3x minus 4 times x squared plus 2x plus 6. A 3 by 3. I'm going to do this one quick. Everything in here multiplied by everything in here one time. So 2x squared times x squared is 2x to the 4th. 2x squared times 2x is going to be plus 4x cubed. 2x squared times 6 is going to be plus 12. 2 times 6 is 12, x squared. Okay, I'm done using this one. 3x. 3x times x squared is going to be 3x cubed. 3x times 2x is going to be 6x squared. 3x times 6 is going to be 18x. And it's a long process, but it's just as easy, really. Negative 4 times x squared, so I'm done using the 3x. Negative 4 times x squared is negative 4x squared. Negative 4 times 2x is negative 8x. Negative 4 times 6 is negative 24. Okay, I'm done using this. I've multiplied every one of these by every one of these in here. Huge polynomial, combined like terms. Okay, so here's my only x to the fourth. So I have 2x to the fourths, 4x cubed, 3x cubed. Okay, so I have 7x cubed. I have 12x squared and 6x squared, so I have 18x squared. I have 18x. Oh, there's another x squared, so I missed that one, minus 4x squared. Okay, so instead of 18, I have 14. 14x squared. 18x minus 8x is 10x, then minus 24. And notice how I just kept them in descending order, and maybe you caught this on the video, I messed up right there. Should have been 2x to the fourth. But notice I have fourth power, third power, second power, first power, no power. Keeping them in descending order will, just organization helps a lot in math. So you try to keep things organized. It's not wrong if they're in a different order. It's just weird if they're in a different order. Okay, so now here's what some of the applications might look like. Well, here we go. Let's do one more before I do one application. I'm going to do this one right here. It says y plus 2 times y squared minus 5y plus 3 minus 3y cubed plus, oops, looks like that, 4y squared minus 6y minus 10. Okay, so order of operations, am I going to be subtracting this first, or am I going to be multiplying these first? So remember, order of operations. So you should be multiplying before you ever get to adding or subtracting. So we multiply these first, and then we can subtract this. All right, so multiplying these first. So again, every term in here by every term in here one time. So y times y squared, y cubed. Y times negative 5y is negative 5y squared. Y times 3 is going to be plus 3y. Done using that. 2. 2 times y squared is 2y squared. 2 times negative 5y is negative 10y. 2 times 3 is 6. Alright, so that's this part all multiplied out right here. Every term in here by every term in here once. I'm going to combine like terms with that first, and then I'm going to rewrite this second part that we've left off so far. So combining like terms, I've got y cubed, negative 5y squared, and a 2y squared, so that's negative 3y squared. 3y and negative 10y, negative 7y, and then plus 6. Now, here's that big parentheses all multiplied. I could put it in parentheses if I want. I don't really have to. So I'm going to now bring back in that other video that we just, hopefully you just viewed as far as adding and subtracting polynomials. We're going to take that and we're subtracting this from it. The whole thing. We're subtracting every single term in there. So I'm subtracting 3y cubed. So remember, that's a negative 3y cubed now. It's going to be a negative 4y. Negative 4y squared. Negative, now here's something interesting, negative 6. So remember, that makes a positive, so we're adding 6y, and a negative 10. So that makes a positive. We're adding 10. Okay, so now I've taken this whole part right here, put it here, right? And now I can combine like terms one last time. So I have y cubed, so I've got 1y cubed here, minus 3y cubed here, so I have negative 2y cubed. I have negative 3y squared, negative 4y squared, so I have negative 7 y squared. I have negative 7y, 6y, so that should be negative 1y. So notice I don't have to put a 1, I just put negative y. Positive 6, positive 10, that's positive 16. Okay, there's that. Here's one last problem, and then I'll end the video. Hopefully it's not too long of a video, but I just wanted to show you what an application to like multiplying polynomials, what an application would seem like. So they would say something like this. You have a square or rectangle. Let's call this one a rectangle. The width of the rectangle is x plus 2, and the length of the rectangle is 3x minus 5. What is the area? What's the area of the rectangle? So you take your width, which is x plus 2, and you multiply it by your length, which is 3x minus 5. The reason you do that is because area is width times length. So here's my width, here's my length. So area is width times length. All right, so multiply it out. 3x squared, x times negative 5. Okay. 2 times 3x. 2 times negative 5. Combine like terms. 3x squared plus x minus 10. So my area equals 3x squared plus x minus 10. So your applications will be something to this effect. They might say, maybe instead of doing this, you have a square, and the side length of the square. The side length of the square is, let's just make it simple, x squared. So that means because it's a square, every side's the same length. So this is x squared, and it's x squared all the way around. What's the area? So x squared times x squared would be x to the 4th. And I just wanted to do that one more simple. And real quick, why not? Sometimes they ask about perimeter. Remember, perimeter is not multiplication, it's addition. So if they say, here's a rectangle, side length is x plus 4, this side length is x squared minus 6, and they say, what's the perimeter? Okay, the perimeter would be adding it all up. So you have x plus 4 plus x squared minus 6 plus x plus 4 plus x squared minus 6. So you have two of these. You have two of these. One for here, and you have two of these. Plus two of these. Two of these. X squared minus 6. And this is another application. So you'd start off by multiplying it, then adding it all together. So I'm going to stop there so the video is not too much longer. All right. So if you guys have questions, ask me after class, in between classes, or during tutoring sometime. See you guys later.